Other types of equations, Part B. In Part A of Other Types of Equations, we talked about radical equations, and I would like to continue that because there are radical equations that could contain more than one radical and look something like this. If you have a radical equation that contains more than one radical, then the first step, as I said in the other video, we are dealing with various types of equations, and in those equations, when we have something that looks a little different, the first step is to get that different looking thing by itself on one side of the equation first. Well, when we're dealing with radical equations, the different thing is, of course, the radical. So we want to get the radical by itself on one side of the equation first. Well, since we have two radicals, we still need to get a single radical by itself on one side of the equation. So what I'm going to do here is I'm going to subtract one of the radicals. I'm going to subtract the square root of 2 minus x from both sides of the equation. And that gives me the square root of x plus 3 equals 3 minus the square root of 2 minus x. Alright, so now we have one of the radicals by itself on one side of the equation. And the way that we undo a radical is a square root, and so the opposite of square root would be to square. So that's what we're going to do, is we're going to undo it by squaring both sides of the equation. And when we square a square root, it just cancels itself out. That's because, for example, if I were to have the square root of 2 squared, that means the square root of 2 times itself, the square root of 2 times the square root of 2. Well, that would be the square root of 4, but what is the square root of 4? The square root of 4 is just 2. So we could just say the square root of 2 squared is 2. It just cancels out the radical. We can skip all those steps and just know that when we multiply a radical times itself, it's going to cancel out the radical. So now since we squared that radical, we just have x plus 3 on the left side. Now on the right side, this is a binomial. A binomial is when we have two terms that are being added or subtracted from one another. And since we have a binomial, we can't just square each part. We have to multiply the binomial times itself. So we multiply 3 minus 2 minus, or the square root of 2 minus x times 3 minus the square root of 2 minus x. And then we're going to have to FOIL that. Okay, so let me bring down the x plus 3. And when I FOIL this right side, I get 9 minus 3 square root of 2 minus x minus 3 square root of 2 minus x. And then like I just showed you, when we multiply a radical times itself, a square root times a square root, it just cancels out the radical. So first of all, that's a negative square root of 2 minus x times a negative square root of 2 minus x, so that would become positive, and then 2 minus x. The radical just cancels out. Okay, so let's combine our like terms. So we have this whole number and this whole number, 9 plus 2, that gives me 11. And then I have this x, there's not another x that I can combine with that, so I'm just going to bring the negative x down. And then we have these terms, the negative 3 square root of 2 minus x minus 3 square root of 2 minus x, and that's going to give me a negative 6 square root of 2 minus x. Because remember, if I had something like this, if I had 2 square root of 3 plus 2 square root of 3, that would give me 4 square root of 3. If the stuff on the end looks the same, it stays the same, and we just add the numbers in front. We add the coefficients of the terms. So that's all we're doing here. since the square root of 2 minus x part is the same, we're just adding the numbers in front. -3 and -3 give me a -6. All right, now that I have all my like terms combined, I want to look at my equation, and I see that I have a radical. And our goal is to get rid of all the radicals and solve the equation. So since I still have a radical, now I want to get that radical by itself on one side of the equation. So I'm going to move everything else over to the other side. I'm going to subtract 11 from both sides and add x to both sides. Okay, so those cancel. X plus x, that's 2x minus 8 equals -6 square root of 2 minus x. All right, so now I have the radical by itself on one side of the equation, so I can go ahead and undo it by squaring both sides. So again, when I square a binomial, I have to write it twice and FOIL it. But here on the right side, that is not a binomial because there's not a plus or a minus in between the terms. It's -6 times the square root of 2 minus x. So because of that, since those are not separated by plus or minus, I can just square that side of the equation. All right, well, if I square -6, that gives me a positive 36. And then once again, when I square a square root, it just cancels out the square root, and I'm left with 2 minus x. All right, so now I'm going to FOIL the 2x minus 8, and that gives me 4x squared. That would be a -16x. -16x, and a positive 64. And then over here on the other side, I would distribute that 36. That gives me a 72 minus 36x. All right, so if I combine like terms, I have 4x squared. And that would be minus 32x plus. All right, everything just disappeared off my screen, so I had to rewrite everything, and I'm not sure if I'm in the same spot as I was in before everything disappeared. So if not, I apologize for that. I think this is about where we were, though. So now I want to get everything over to one side of the equation. I'm going to subtract 72 from both sides. And I'm going to add 36x. And that gives me 4x squared plus 4x minus 8 equals 0. Okay, so to solve this is just a quadratic equation. So I'm going to factor to solve. And if I look at this, I see that there's a greatest common factor of 4, so I'm going to factor that out first. And once I do that, I have a trinomial, and I'm going to factor that trinomial into two binomials. The only factors of x squared are x and x. The only factors of 2 are 2 and 1. And since my first sign is positive, that's going to go with my biggest number. And this is my factors. Okay, so then I would take each factor and set them equal to 0 and solve. Well, if I set 4, this 4 right here, if I set it equal to 0, 4 doesn't equal 0. So I can just kind of discard that because that's not true. But the other two factors, the x plus 2 and the x minus 1, if I set those equal to 0 and solve, I get that x equals -2 and x equals +1. Okay, now remember, when we're dealing with radical equations, we have to check to see if our solutions are extraneous. So I'm going to check that first solution. I'm going to check the -2 in my equation and see if it works. All right, so if I plug -2 into my original equation, -2 plus 3 plus 2 minus a -2 equals 3. All right, so a -2 plus 3, that is 1. And 2 minus a -2, that'd be like 2 plus 2, which is 4. So the square root of 1 is 1, the square root of 4 is 2, and 1 plus 2 is 3. So that works. That is a solution of my equation. All right, now let's check 1. Let's see if 1 will work in the equation. If I plug in 1 plus 3 plus 2 minus 1, I get the square root of 4, the square root of 1, well, okay, so the square root of 4, let's bring it up here. The square root of 4 is 2, the square root of 1 is 1, and that gives me 3. Okay, so that works also. So 1 is also a solution to my equation. But remember, in radical equations, a lot of times we'll have extraneous solutions, so it's important that you check both possible answers to see whether or not they are extraneous. Here is another type of equation. We're going to be solving radical equations in the form x to the mn power is equal to k. These are also called equations with rational exponents. So remember the word rational in math when we're talking about rational terms or rational equations, they mean fractions. So if I have a rational exponent, that means that my exponent is a fraction. So we're going to assume that m and n are positive integers in its lowest terms, and k is a real number. Just like I said before, when we have something that looks different in an equation, the first thing we want to do is isolate that different looking thing. So the first thing we're going to do is isolate the expression with the rational exponent. Then, to get rid of that rational exponent, we're going to raise both sides of the equation to the reciprocal power. So if you'll notice, the power was mn. We're going to raise both sides to the nm power. So we're going to flip it and raise it to that reciprocal power. Now, if the denominator of whatever we raise the power to, if it's even, we need to put plus or minus in front of our term. Okay, so this is what I'm saying. If m is even, so if this is even, when I flip it, if that bottom number is even, we need to put plus or minus in front of our equation. However, if it's odd, we do not put plus or minus in front. Now, the reason for that is, remember, when we have a rational exponent, the bottom number is the root of our term. So if our root is even, if we have a square root or a fourth root or a sixth root, we always put plus or minus in front. If it's an odd root, if it's a cube root or a fifth root or so on, we do not put plus or minus in front. And then we always, we can check our solutions to make sure that they're good. We don't have any extraneous solutions. Okay, so before we actually start trying to solve these types of equations, let's refresh our memories with what these roots mean. So just like I was saying, when we have a rational exponent like this, the top number, or the numerator, is the power. Yeah, hold on. All right, the top number is the power. The bottom number is the root, or the index of the root. So the way I remember which is I know that roots grow on the bottom. If we have a plant, the roots are on the bottom. Well, whatever number's on the bottom, that's the root. The top number is the power. So if we were going to rewrite this expression as a radical, then we would take the bottom number, and that would be my root. And the top number is my power. Oh, it's not a 3, it's just a 1. So since it's a 1, we don't put anything out there. Actually, we don't even need to put those parentheses. It would just be the square root of 64. For b, we have 27 to the 1/3 power. So instead of a square root, that would be a cube root of 27. Now for c, this is 4 to the 3/2 power. So again, the bottom number is the root, so that's the square root of 4, and it's being raised to the 3rd power. All right, for number 8, that's 8 to the 2/3 power. So what is the index of my root? My index is going to be a 3, so it's the cube root of 8. And then my power is 2. All right, so that was just a little refresher on what those rational exponents mean. Now let's solve an equation that has a rational exponent. All right, so remember, the first thing we want to do is get the different looking thing by itself. Okay, so the thing that's being raised to the rational exponent is not 5x, but just the x is being raised to that power. Okay, so we want to get just that part by itself on one side of the equation. So I'm going to add 25 to both sides. And then to get that 5 off of the x, I'm going to divide by 5. All right, now that we have isolated the rational exponent, or the term with the rational exponent, we're going to undo it, and we undo it by raising it to its reciprocal power. All right, so we're going to raise both sides. The power right now is 3/2, so we're going to flip it to be 2/3. And we do that to both sides. Now, like I said, whatever number is in the denominator of what we raise it to, so we rose it to the 2/3 power, our bottom number, our denominator, is a 3. That's an odd number, so we don't need to put plus or minus in front. If our bottom number or our denominator was even, we would need to put plus or minus in front. Okay, so now when we raise the power to its reciprocal right here, it cancels it out. Let me show you why that is. Okay, so if I have 3/2 and I multiply it times the reciprocal, 2/3, if I multiply that, when we multiply fractions, we multiply the top times the top, bottom times bottom, and I would get 6/6. Well, what is 6/6? That's 1. So really, this just becomes x to the 1 power, which whenever we have a power of 1, we don't write it. It's understood to be there. So it's just becomes x equals 5 to the 2/3 power. Now, we could stop here, but we always want to make sure that it can't be simplified any farther. So it's always best to go ahead and change it to a radical and see if you can simplify it. In this case, this would be my bottom number is my index of my root, so that would be the cube root of 5 squared. Now, I can't take the cube root of 5. And if I did it in the other order, if I raised it to the second power and then took the cube root, 5 squared is 25. I still can't take the cube root of 25. So I can't go any farther. So this is my answer. But if it can be simplified, you want to do that. Let's look at another one. All right, what is being raised to the power here? What's the different looking thing here? Again, it's the x. So we want to get it by itself. I'm going to do that by adding 8 to both sides of the equation. And I have x to the 2/3 power equals 4. All right, so now I'm going to raise both sides. Let me move this over just a little bit. I'm going to raise both sides to the reciprocal power. Now this time, when I raised, the power that I raised it to is 3/2. My denominator is even, so I need to put plus or minus in front of my number. Okay, on where the x is, those powers cancel out or change to a 1, so all that's left is the x equals plus or minus. Now let me go ahead and change this to a radical so I can see if I can reduce this or simplify this. Okay, so my bottom numbers are 2, so that would be the square root of 4 raised to the 3rd power. Okay, so we can take the square root of 4. The square root of 4 is 2, and then 2 to the 3rd power is 8. So I actually have two answers here, plus or minus 8. All right, what is being raised to the rational exponent here? It's the whole x minus 4. So it's already by itself on one side of the equation, and my next step would be just to raise it to the reciprocal power. So I'm going to raise both sides to the reciprocal power, which would be 3/2. And since the thing that I'm raising it to, since my denominator is even, I need to put plus or minus in front of my number. All right, so these two will just cancel each other out, and I'm left with x minus 4 equals plus or minus. That would be the square root of 16 cubed. All right, so the square root of 16 is 4, and 4 cubed is 64. All right, so now I need to get x by itself. I'm trying to solve for x, so I'm going to add 4 to both sides, but I'm not adding 4 to 64. I'm adding 4 to 64 and to negative 64. So I need to work those two separate solutions out. If I have a positive 64 and I add 4, then that gives me 68. But if I have a negative 64 and I add 4, that gives me a negative 61. So make sure if the plus or minus is not just in front of your solution, if it's in front of something and then you have to take another step, you need to separate that and work it out with the positive number and with the negative number, because it gives you two totally different solutions, a positive 68 and a negative 61. All right, the last different type of equation that we're going, or other type of equation that we're going to talk about, is absolute value equations. So first we need to define absolute value. Absolute value denotes the distance a value is from 0 on the number line. So the absolute value of a number is how far a number is from 0 on the number line. So since we're talking about distance, it can never be negative. If I say, what is the absolute value of 5? The answer would be 5 because it's 5 spaces from 0. if I said, what is the absolute value of negative 5? It would still be 5 because negative 5 is 5 spaces from 0 on the number line. We can't have a negative distance. An absolute value equation is, of course, an equation that contains an absolute value expression. When we rewrite an absolute value equation without the absolute value bars, we have to write it with both possible solutions. Meaning, if I were to take this absolute value equation right here, the absolute value of x equals c, that means that x could be positive c or it could be negative c. Just like I was just saying about the 5, the absolute value of 5 is 5, and the absolute value of negative 5 is also 5. So that means whatever is in here, in the absolute value bar, it has to be positive or negative. So x has to be either positive c or negative c, or actually it's both. X is positive c and negative c because both of those would equal that same distance from 0 on the number line. All right, so when we're going to solve an absolute value equation, that's what we do. When we take it out of the absolute value, when we take this equation and we remove the absolute value bars, we say that that thing inside the absolute value could be positive or it could be negative. So to solve these absolute value equations, the absolute value of x equals 10. That means that x could be 10 or it could be negative 10. So once we get the absolute value by itself, and again, that's going to be the first step in solving an absolute value equation. The absolute value in this case is the different looking thing. We want to get it by itself on one side of the equation, and then when we take it out of the absolute value, we set it equal to the positive and to the negative. Now, B says the absolute value of x equals negative 10, and they want us to solve that. Well, here we would say that there is no solution. Anytime we have an absolute value equal to a negative, that's not possible because that's saying the distance that this is from 0 on the number line is negative. Okay, well that's not possible, so there's no solution. Alright, so here we have the absolute value of 2x minus 5 equals 5. Okay, so remember our first step is to get the absolute value by itself on one side of the equation. And that's already done. Once that's done, the next step is to take it out of the absolute value and set it equal to the positive and to the negative. Alright, so we're going to take it out to x minus 1, and that equals positive 5. But we're also going to say that it equals negative 5. Alright, and then we just solve these. So I'm going to add 1 to both sides. And then divide by 2. So I get x equals 3. For the other equation, I'm going to add 1. And I have 2x equals negative 4. Divide by 2. And x equals negative 2. Alright, so let's just check these to see if they work. So if I check them by plugging them into the original equation, I have to plug it in exactly into what we started with. Alright, so that would be 2 times 3 minus 1 equals 5. Alright, so inside the absolute value, I want to simplify that first. So that would be 6 minus 1 equals 5. Well, 6 minus 1 is 5. And the absolute value of 5 is 5. Alright, so then for the other side, if I plugged in a negative 2, 2 times negative 2 minus 1 equals 5. All right, 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. But what is the absolute value of negative 5? It's 5. So both of these solutions work. All right, let's try this one more absolute value equation. Okay, so remember the first step is to get whatever is in absolute value by itself on one side of the equation. So this is what's in the absolute value, and I want to get it by itself. So I'm going to add 20 to both sides first. And I have 4 times the absolute value of 1 minus 2x equals 20. And then I want to divide both sides by 4. And that gives me the absolute value of 1 minus 2x equals 5. All right, so if we were to work something like this out, if at this point, once I got the absolute value by itself, say if this said the absolute value of 1 minus 2x equals negative 5, we would stop there and say, no, that's not possible. The absolute value cannot equal a negative, and we would stop and say that there's no solution. But that's not the case here. This says the absolute value of 1 minus 2x equals a positive 5. So we're going to take our expression out of the absolute value and write it one time just like it was, and then write it again equal to the negative. And then solve. Okay, so I'm going to subtract 1 from both sides and divide by negative 2. And then on the other side, I'm going to subtract 1, divide by negative 2, and I get x equals 3. So those are my two solutions. Just caught a mistake. And of course, you can always catch your mistakes if you check your solutions. In my first, this right here, when I divided 4 by negative 2, I should have gotten a negative 2. So my solutions are x equals negative 2 and x equals positive 3. And again, all you have to do is plug those in any place you see an x in the original equation and work it out. And if it doesn't come out to be right, it's either an extraneous solution or you made a little mistake. So if one of those happens to be wrong, double check your work before you finish your problem.